Hello students, in previous lecture we have studied about the theorems, that is which is related with the properties of triangles. That is BPT theorem and angle bisector theorem and converse of BPT theorem as well as angle bisector theorem, and few examples from practice set 1.1 and 1.2 we have already solved from it. Then one more property which is based on BPT theorem, that is basic proportionality theorem. That basic proportionality theorem is used in different concepts of geometry, and therefore one more property which is related with the property of three parallel lines and their transversal. First of all, see here, there are three parallel lines, that is line L, line M and line N are parallel to each other, and there are two transversals, that is T1 and T2, two transversals which intersects line L, M and N in three distinct points. Then because of that, the intercept that is AB, BC, which is made on transversal T1 by these three lines, as well as intersect PQ and QR, which is made by these three lines on T2 transversal. Then the ratio of these intercepts are in the proportion or are in the equal ratio. Then see here, theorem or property of three parallel lines and intercept made by transversal, made on the different transversals by the same three parallel lines. That is, see here, the ratio of intercepts made on a transversal, made on one transversal, that is there are two intercepts made on T1 transversal by these lines L, M and N, parallel lines, that is made by three parallel lines, is equals to the, that is ratio of these two, that is AB upon BC, it is equals to the ratio of corresponding intercepts made by any other transversal on the intercepts made by on other transversal, that is T2 transversal, by the same parallel lines. Then first of all we have to write the given concepts, that is, see here, line L parallel to line M parallel to line N, that means these three lines are parallel to each other. Then see here, T1 and T2 are the transversals on which intercepts are formed, that is, see here, T1 transversal intersects line L, line M and line N at point A, B and C. Similarly, T2 transversal intersects to the same lines, that is line M, line N and line L at point P, Q and R. Then see here, therefore intersects are formed on those transversals. Then we have to prove that, see here, ratio of intersects of formed on one of the transversal, that is AB upon BC, is equals to the corresponding intersects on another transversal, the ratio of these two, that is PQ upon QR. Then first of all we have to do some constructions. Then see here, the construction made here, that is draw PC, that is draw segment PC, draw segment PC. Then we can prove the property, that is proof. See here, again the line L parallel to the line M, parallel to the line N, and therefore if we draw the line segment PC, then here triangles are formed, that is, see here, triangle ACP. Focus on only this triangle, that is this triangle, that is, see here, line L parallel to line M, parallel to line N, and T1, T2 are the transversals. Then if PC is drawn, then in triangle ACP, in triangle ACP, see here, in triangle ACP line, that is PC is drawn, which intersect line M at point D, at point D. Then in the triangle ACP, BD parallel to AP, because line L parallel to line M. Here AP parallel to the BD. Therefore, see here, in this triangle BD parallel to AP, therefore the ratio of, according to the BPT theorem, AB upon BC is equals to PD upon DC. Therefore, AB upon BC is equals to PD upon DC. Let this equation number 1. Similarly, see here, the another triangle is also formed here, that is triangle PCR. Then in triangle PCR, R. Now see here in this triangle PCR, DQ parallel to the CR, because line M parallel to line N, that is given here. Therefore, DQ parallel to CR. Therefore, according to BPT theorem, by BPT theorem, we have to write PD upon DC is equals to PQ upon QR. PD upon DC is equals to PQ upon QR. PQ upon QR. Let this equation number 2. Then see here, focus on the equation number 1 and 2. See here, AB upon BC is equals to PD upon DC. But here PD upon DC is the PQ upon QR. Therefore, from equation 1 and 2, from equation 1 and 2, AB upon BC is equals to PD upon DC, but PD upon DC is the PQ upon QR. PQ upon QR. Then see here, AB upon BC is equals to PQ upon QR. That is the proof of this theorem. That is the property of three parallel lines and their transversal. First, we have to remind this property, then we have to solve the examples based on it. Then see here, the ratio of intercepts made by one of the transversal, made on one of the transversal, that is T1, made by three parallel lines, is equals to the ratio of intercepts made on another transversal by the same three lines. That is the theorem of three parallel lines and their transversal. Then we will solve one more example from practice set 1.2, which is based on BPT theorem. Then example question number 4, that is given in the practice set 1.2. Then see here in the figure, the triangle which is that, see here, triangle ABC is given here and PQ is the line segment which divides to the side AB at point P and the side AC at point Q. And here the angles, measurement of angle APQ is given here, that is 60 degree, and measurement of angle ABC or PBC, that is also 60 degree. Then we have to prove that AP upon PB is equals to AQ upon QC. Then first of all, write the given concept in the examples. See here, in triangle ABC, then AB, BC and AC are the three sides of triangle ABC, and the line segment PQ intersect to side AB at point P, and the line segment PQ also intersects to side AC at point Q. Then here one more parameter is given here, that is angle of, that is angle APQ is equals to 60 degree, and angle PBC is equals to also 60 degree. Therefore here angle APQ is equals to angle PBC. That means these angles are congruent. Therefore here PQ parallel to BC and transversal AB is considered. Therefore PQ parallel to the segment BC and the transversal AB is considered here, because PQ and BC are parallel, because here corresponding angles are congruent. That means it is a corresponding angle test, which is studied in 9th standard. Corresponding angle test, alternate angle test and interior angle test. That is because of corresponding angle test PQ parallel to BC. Then see here, in triangle ABC, PQ parallel to BC, that is which is proved here. We have already proved this. Then see here, according to BPT theorem, if the line parallel to the one of the side of triangle, then that line divides the remaining two sides are in equal ratio. Therefore, by BPT theorem, by basic proportionality theorem, AP upon PB is equals to AQ upon QC. That is the proof of this example. You can solve different types of examples which is given in the practice set 1.2, which is based on BPT theorem, converse of BPT theorem. as well as angle bisector theorem and converse of angle bisector theorem, as well as the examples which is depends upon the property of intercepts, ratios of intercepts made by three parallel lines on the different transversals. Then we will solve two more examples from practice set 1.2. See here, we have studied about the theorem of ratios of intercepts made by different transversals of same parallel lines, and the example which is based on that property is given in the question number 7 from practice set 1.2. Then see here in question number, example number 7, that is here three parallel lines are given here, that is side AB or segment AB parallel to segment CD parallel to segment EF. Then these three line segments are parallel to each other, and there are two transversals, that is we have to denote it, that is T1 and T2, and there are T1 and T2 transversals are there. T1 transversal intersects line AB, line CD and line EF at point B, D and F respectively. Similarly, T2 transversal intersects line, the same line AB, line CD and line EF at point A, C and E respectively. Then we have to mention these given points while solving examples. We should not write the direct solution or direct property or theorem of that concept. Then see here, the intercept made by these three parallel lines on T1 and the intercept made by the same three parallel lines on transversal T2. Then according to the by property of three parallel lines and transversal, then we have to write BD upon BF is equals to AC upon CE, putting the values of BD, DF, AC and CE. That is, BD is given here 8 upon DF, that is 4, is equals to AC is given here 12 upon CE, that is X is given here. Therefore, to solve this, we will get the value of x. Then simplifying this equation, we get 4 ones are 4, that is 4 twos are 8. Therefore 2 is equals to 12 upon x. Therefore 2x is equals to 12. Therefore x is equals to 12 upon 2. Therefore x is equals to 6. That means here value of x is equals to 6. Similarly, we can solve one more example from practice set 1.2, that is example number 9. Then see here, in this example, in triangle ABC, B, that is BD is the angle bisector of angle ABC, because here the congruent signs are given here, that is angle ABC is equals to angle DBC, that is given. Therefore BD is the angle bisector of ABC. According to or by angle bisector theorem, we have to write, that is AD upon DC is equals to AB upon BC. Putting the values of the line segments given here, that is AD is x minus 2 upon BC is x plus 2 is equals to AB is given here, that is x upon BC is x plus 5. Then simplify this equation, that is cross multiplication should be done here. Before cross multiplication, we have to put down the bracket to these values, or here in numerator and denominator of both ratio. Therefore here x minus 2 into x plus 5 is equals to x plus 2 into x. Therefore solving this equation, see here, x minus 2 into x plus 2, that is binomial into binomial. We have already solved these type of examples in previous standard. Therefore we can write directly, that is x square minus 2x plus 5x minus 5 into 2, that is 10, is equals to, here binomial by monomial, that is x into x plus 2, that is x square plus 2x. Therefore rearranging these equation, here x square minus 2x plus 5x, that is 3x minus 10 is equals to x square plus 2x. Here x square get cancelled and we get the simplified equation, that is 3x minus 10 is equals to 2x. Therefore here reshuffling the equation, we get 3x minus 2x is equals to 10. Therefore, 3x minus 2x, that is x, is equals to 10. Then here, value of x is obtained here, but we have to find out the values of, that is lengths of all line segments, that is AD, DC, BC and AB. Therefore here x, that is the length of AB, therefore AB is equals to 10 units. Similarly, AD is equals to x minus 2, that is 10 minus 2, that is AD is equals to 8. Similarly, DC is equals to 10 plus 2, that is DC is equals to 12. And here BC is x plus 5, that is 10 plus 5, that is BC is equals to 15. Then see here, we can solve these type of examples from practice set 1.2. Then do the practice of solving the examples from practice set 1.2. Thank you.